Okay, next one. Of the members of a bowling league, 10% are widowed. If 200 bowling league members are selected at random, find the probability that 10 or more will be widowed. So again, we want to find the probability of 10 or more. So x is greater than or equal to 10. We need to find our mean. That would be 200 times 0.1, which would give us 20. So again, we expect 20 of these 200 women, I guess I assume they're women, of this bowling league to be widowed. Standard deviation, again, I usually just put the 20 in there because that's already the n times p times 0.9 would be your q. And that gives us 4.2. So when you think about drawing your picture, I know usually we wait and draw our picture at the end, but here's what you need to think. This would be 20. So 10 is going to be way down here. And we want greater than or equal to. So that means we need to include this line, which means we need to go over here. So you need to use 9.5. So we need to know the probability that x is greater than, x is greater than 9.5. So what we do for our z-score then is we do 9.5 instead of 10, minus 20 over 4.2. Again, if you do this whole problem and you use 10 instead of 20, you're only going to get a half a point off. So if you're really worried about this, don't be. All right, so then we do that and we get negative 2.5. So that's a really small kind of z-score. If you think negative, it's a big z-score. If you think of it the positive way. Again, we'll just look that up. So when you look that up, again, if you look up negative 0.25, that's going to give you this amount, which is 0.0062. So we need to subtract that from 1. Or if you look up positive 0.25, you're going to get your answer right away, 99.38. So 99.38% probability that 10 or more will be widowed. So that's a huge percentage, obviously. That's almost 100%. That should make sense. Again, it all goes back to this. You expect 20 people to be widowed. You're asking about 10 or more. So that's 10 all the way up through 20 that you would expect. So it is very, very likely that 10 or more. Okay, again, you expect 20 to be widowed, so 10 or more should be very likely, which it is very, very likely. Last one. If a baseball player's batting average is 320, find the probability that the player will get at most 26, I always mean to change this, but I forget, hits in 100 times at bats. So those of you that don't know baseball, this is just a percent. So he gets a hit 32% of the time. All right. So at most 26, that would be the probability that x is less than or equal to 26. Okay, at most 26 means he could get 26 or less, so less than or equal to. Our mean is going to be 100, that's how many times at bat, times 0.32, 32%. So that would be 32. So you expect him to get 32, so you should already be thinking, should this be a high percentage or a low percentage? We want less than or equal to 26, and you expect 32, so that probably shouldn't be very high. Standard deviation, square root of 32 times 0.68, and that gives us 4.7. So again, if you think about drawing this before you put the z values in, your mean is 32, we want 26 or less than. All right, so if it helps you to draw in the real numbers rather than your z-scores, obviously that's fine. So again, we do want to have 26, so that means we need to go over on this side of it. So we need to use 26.5 when we do our z-score. So 26.5 minus 32 over 4.7, negative 1.17. So again, that's what you're going to look up, which will give you the exact, so this is negative 1.17. That's what you want to look at. That will give you your 12.1%. So not super likely, but not a super tiny percent either. All right, that's it for Chapter 6. I'm going to post some practice problems for you to do if you want to do those as well as your assignment, which is due on Monday.